Finally, let's look at numbers 8 and 9 on the week 4 lab. Let me pull up that page in the book. It says using all four of the properties of a binomial experiment. See page 201 in the textbook. Explain in a short paragraph or several complete sentences why the coin variable from the class survey represents a binomial distribution. But let's take a look at that in the book. I love this textbook being online. Some people don't like it. I really like it. If you will look on page 201, let's see if it'll let me make it larger. Yeah, cool. It says, well, I said it was cool, but let me move it over here and see if it'll let me move it around some. It says here, a binomial experiment is a probability experiment that satisfies, it's not going to let me do that. There we go. That satisfies these conditions. The experiment has a fixed number of trials. Think about that. When you flip that coin, how many times did you flip it? Where each trial is independent. You need to put this in your own words. When you flip a coin, is it independent? In other words, does the second flip have anything to do with the first? No. There are only two possible outcomes. Well, what are the possible outcomes when you flip a coin? The probability of success stays the same. Yeah, I think you could make that argument. A random variable x counts the number of successful trials. Okay, well, I think you can explain that too in terms of that. So you need to explain this definition, how it applies to flipping that coin and why it would or would not be. Of course, you should see that it is a binomial experiment. Let's take a look at number 9. On number 9, it says compare the mean and the standard deviation for the coin variable in question 2 with those of the mean and the standard deviation for the binomial distribution that was calculated by hand in question 5. Now, remember, I did a different question. I changed my number, so this is not your answer. But for mine, this is how I would do it. I would have said my mean from question 2 is 4.257. My standard deviation from question number 2 was 1.738. The mean from question 5 was 4. The standard deviation from question 5 was 1.549. The values in number 2 were calculated using actual data. Remember, that's from my data sheet. The results in number 5 were calculated using a mathematical formula based on n and p. I would expect the results from the actual data to get closer and closer to the formula results as I got more and more data. In other words, if I flipped that coin a bazillion times and my probability was truly 2/5, I would expect this mean to get closer to this, and this standard deviation, this to get closer to this 1.549. But since I just did it based on 10, that explains the little difference there. So anyway, an easy one. Hopefully this helped you. I'm sorry about the technical difficulties. Again, I will say I love doing this for you guys. It's one of my favorite things to do. I don't like having to do it over, but when I have to, I have to, and I hopefully have figured this out on how to help you. Take care now.